Um, okay, I feel like that's like all the participation I'm gonna get. So, fluorine is the most electronegative element. That's super important. You do need to know that. An atomic radii is going to decrease from left to right. Okay, cool. So how do you guys feel about quantum numbers? You can like unmute yourselves and like participate. That's cool.
I feel pretty good. Not
You
that
do?
hard,
Okay.
but I've also been through
I'm
this.
not really good at them.
Okay, okay. Okay, cool. So, I'm going to go ahead and start sharing. So, what are the 4 different orbitals?
S, P, D, and F.
S, P, D, and F. And okay, what's the shape of these orbitals? We went over shape, correct? Okay, cool. So what does the s orbital look like? What's its shape?
It's a sphere.
Yeah, it's going to be a sphere. What about the p orbital?
A dumbbell.
Dumbbell. She likes to use that one. I don't know why I don't like dumbbell, but if that works for you, you can use it. I prefer peanut because peanut starts with a P and it tells you the exact same shape. What about D?
What?
Like a flower.
Like a, so I have a clover as mine. The F orbital has like, it's just weird. It's weird. There's no defined shape. It's weird.
We didn't really go over D and F. She just like said they're complex yesterday.
Yeah, that's true. A clover is honestly like quite a simplified version of the d orbital, but it's the sort of like best way to try and define it. But yeah, they're really complex, especially the f orbital. So each can hold a certain number of electrons. How many electrons can the s orbital hold?
2.
2. What about the p orbital?
6.
6. D
10.
and F
14.
14. And if you ever forget that, if you go to that orbital block on the periodic table and you count across, it's the exact same. Define the Pauli exclusion principle. What is the key point of this principle? So this is a bit of a definition type thing. Does anyone remember?
No 2 electrons in the same atom can have the same set of quantum numbers.
Yes. That is spot on. So what qualifies as ground state?
Is it just like with no charge?
Yeah, it just means no charge. It's neutral. We went over this yesterday. So what are the three components of writing an electron configuration?
The energy level, the orbital, and the number of electrons.
Yes. Exactly. So, okay. Draw the orbital diagram for the electron configuration of oxygen. How many unpaired electrons are there? So I have a board, but I don't know how to make this like. I don't know how to like make this not backwards, so I'm going to like try my very best, you guys. We're gonna figure this out together. No, that'll be backwards. Okay. So what I mean by the orbital diagram is just like the lines. So what is the electron configuration of oxygen?
One S2.
1s2?
2s2. And then 2p4.
Okay. You guys see that? That's backwards, isn't it?
No.
No? You guys can read? Oh, awesome. Okay. So what I mean by orbital diagram is just these lines. So we're going to have the 1s orbital, we're going to have the 2s orbital, and then we're going to have the 2p orbital. So the amount of lines you have is the amount of electrons it can hold divided by 2 because electrons typically work in pairs. So we have 1s2, 2s2, and we have 2p4. So this is where it gets kind of weird. And this is going to go to the Aufbau principle, okay? This is also going to come down to another principle that I have listed in here that I can't currently recall the name of. But basically, you're going to go 1, 2, 3, and then you're going to cycle back and make a pair. Does that make sense? So you have to have at least one on each line before you can start making pairs. So this would be your electron or your orbital diagram. So based on this, how many unpaired electrons are there in oxygen?
2.
2. These two. Okay. So what I mean by this, how do d orbitals and f orbitals relate to s and p? So what I'm talking about is the energy levels that they follow. So think about it. If you have 4s, what is the energy level for d going to be?
One less, so it'd be 3D.
Yeah. So our d orbitals is going to lag by 1. What about F?
It's behind by 2, like you subtract 2
Yes.
from S and P.
What space there? Yeah, our F is going to lag by 2 energy levels. So while you have 6s2, you'll have 4f whatever. You could have like 6s2, 4f14, 5d10, and then 6p whatever. Okay. What are our 4 quantum numbers?
N, L, ML, and MS.
Yes. I'm going to put it in parentheses, but I really mean a subscript. It's just it takes a while to do that on this. I mean, it doesn't, but more time than I'm willing to put in. What does N denote?
The energy level.
Energy level. And what about L? Which quantum number is L?
Orbital.
Yes, this is going to be our orbital shape. What about M sub L? Starts with an M.
Magnetic.
Magnetic. And finally, M sub S.
Isn't that the spin?
Spin. Okay. So I'm going to give y'all a quick 3-minute break, just because my answer key is on my phone and my phone is on 1%, so I need to grab my phone charger from my room really quick. But I won't take long. I'm so sorry. I'm not totally prepared like I should be, but I'll be right back. Okay, not even 3 minutes. Okay, cool. Okay, so this is really repetitive. So what determines the N quantum number?
Energy level.
Energy level. What determines the L quantum number?
Orbital shape.
Orbital shape. Okay. Okay, here's where it stops getting so repetitive. What's going to determine our M sub L quantum number?
The amount of electrons.
Right, so the way that, number of electrons, or if you like the orbital diagram, I go based off of position orbital diagram. So what's going to determine our M sub S?
Like which way the arrow's pointing.
Yeah, so arrow direction. So draw a diagram depicting all the possible L quantum numbers. So here's how I'm going to do that. So L quantum numbers based on what again?
The orbital.
Orbital shape. So we have S, P, D, and F, right? So if it's S, it'll be 0. If it's P, it'll be 1. If it's D, it'll be 2. And if it's F, it'll be 3. Or another way you could do that is like 0, 1, 2, 3, S, P, D, F. Yeah. Okay. So does everyone feel like comfortable with this? Cool. So now draw a diagram depicting all of the possible L quantum numbers. So this is why I really like, I'm gonna move my laptop so you can see this better. This is why I really like drawing out my orbital diagrams. So here you have your S orbital, your P orbital, your D orbital, and 1, 2, 3, 4, 5, 6, 7, your F orbital. So this is going to be based on, like I said, the position in your orbital diagram. So we're going to go 0 at the center of each. And now you're just sort of creating a number line. So is this a little confusing right now, or does this make sense looking at it? If it is confusing, we're going to get to an example where we get to like actually work with this. So just remember this, keep it in your notes, keep it handy. Okay. And now we're going to go to draw a diagram depicting all of the, that's what we just did, sorry. So what are all of the possible M sub S quantum numbers?
Positive and negative 1/2.
Yeah, you can only have positive or negative 1/2. Oh, what the heck? And honestly, if you aren't given a diagram, you're just asked what are the last, or what are the quantum numbers, you can choose whichever one you want. It does not matter.
Just make sure your arrow is pointing the right way.
Yeah. Yes. Thank you, Emma. Yes, exactly. So write the electron configuration of strontium. So what is our electron configuration?
One S2, 2S2, 2P2, 2P6. Strong. 3S2, 3P6, 4S2, 3D10, 3P6, A 4
Oh, yeah.
would be 4. Yeah, 4p6. And then 5s2.
5s2. Okay. So what would be the the noble gas configuration?
Krypton. 4p6.
Hmm?
Or would it just be 5s2?
Yeah, because Krypton is covering us all the way up until this P6.
Okay.
So how many unpaired electrons are there?
None.
None. Because if you think about your s orbital, you're going to have this line, and then you have 2 here, so you have 1, 2, and that covers you. So what are the quantum numbers for the last electron? Okay. So you can do this one of 2 ways. Well, I guess one of 3 ways. 1, you can totally ditch the orbital diagram and not do it at all. 2, you can do the orbital diagram for all of these orbitals. But I don't know about you guys, but I'm going to go with option number 3, which is to just draw the last orbital since we're only looking at the last electron. And I am lazy and I don't want to draw all of the orbitals. So I'm going to stick with this 5s orbital. So based on our electron configuration, we're going to have 2 here, right? So we're focusing on the very last electron. Okay, so we need our N, our L, our M sub L, and our M sub S. What is our N?
N is 5.
5. What about our L?
0.
0. And that's based off of our S, right? What about our M sub L?
0.
0. And that's based off of which line it's on. The s orbital only has 1 line, and that line can only be 0. So if this is 0, this has to be 0. What about our M sub S based on what I've drawn up here?
-1/2.
-1/2. So these are your quantum numbers, 5, 0, 0, -1/2. Okay. Write the electron configuration for chromium 2+. Honestly, how do you guys feel about electron configurations? Good. Let's go ahead and do this one. Give me the noble gas configuration.
AAR 4s2 3d2.
Yes. 4s2 3d2, perfect, with argon at the beginning. So draw a diagram that depicts an electron configuration that violates the Pauli exclusion principle. So we talked about that up here, right? Yeah. So what does the Pauli exclusion principle say again?
No two electrons can have the same quantum number.
No two electrons can have the same quantum number. So I'm going to show you how that's going to happen. So I'm going to give us 1s and 2s. I'm going to show you the right way and then the wrong way. So let's say we have 1s2, 2s2. That's our electron configuration for whichever element that is. So looking at this, we're going to go 1, 2, 1, 2. That's the correct way, right? Whereas something that would violate the Pauli exclusion principle would be something like this. Because these two would have the exact same quantum number. Okay. Number 20, label the following sets of quantum numbers as valid or invalid. So this is a question that I pulled either from a past exam or a past quiz, one of the two. Either way, this is a question. This is a question that was written by Ms. Adams. So you can guarantee you will see a question like this on your exam. So let's walk through this. So let's take a look at A. A is telling us that we are in the first energy level and our L number is 1. What does that mean?
S.
Ooh, what is S? P, yeah.
P.
We're in 1p, 1. So if this is our p orbital, where is that last electron going to fall?
Is it the?
It's going to be here.
Is that what you're saying? Oh,
Like,
okay.
yeah. And just like which line is it going to be on? And it's a positive 1/2, so it's going to be facing upward. Does this make sense? Is this valid?
I don't really understand why it's to the right now.
So it's because when we have this, we're going to have 0, +1, and -1.
Oh, okay. That
Yeah.
makes sense. Never mind.
And that's going to be for your M sub L. So is this valid? Does this look right? Does 1p exist?
Yes.
1p does not exist. So we go straight from 1s to 2s, and then we hit 2p. 2p is our very first p orbital. So A is going to be invalid. I'm gonna put my marker here. Okay, let's move on to B. So we're in energy level 3. What orbital are we in?
P.
P. So let's draw out this P. We're going to have 0, +1, -1. It says our M sub L is -1. Does that fit? Yes. It's going to be facing upwards because we have that, or just kidding, it's going to be facing downwards because we have a negative 1/2. Does this make sense? Is this valid? Someone?
Yes.
Yes. This is going to be a valid set of quantum numbers. Okay, moving on to C. We're going to be in the second energy level. Our L is 0, so what orbital is that?
S.
S. And we only have one line, which is 0. It puts us at 0. Is this valid?
Yes.
Yes. So letter C is going to be valid. So looking at D, we're in the first energy level. What orbital?
S or P.
E. You guys remember part A? This does not exist. It cannot exist. So automatically, we don't have to do anything else. We already know this
One
is valid.
doesn't exist, right?
What is it? Can I say something? No. Okay, so 1p can't exist, so D is invalid. And lastly, E, we're in the first energy level. What orbital?
S.
S. Our M sub L is 0, so that puts us here. Our magnetic is, our spin is an upward arrow. Is this valid? Yes?
Yes.
Yes. Okay. So now, what is the electron configuration of Ga, and what are the quantum numbers for the last electron? So what's the noble gas electron configuration?
Argon.
Argon?
Rest. 2. 3d10. And 4p1.
4p1. Perfect. So what is our N quantum number?
4.
4. What about our L quantum number?
P or 1.
1. Our M sub L?
-1.
-1. And M sub S?
+1.
Since there's no diagram, it can honestly be either, but I always draw my arrows upwards first, so I do +1/2, because where these two are going to come from is from our orbital diagram, so we're going to say this is 4p. We only have one electron. It's going to go right here. If you draw that downwards, it'll be -1/2. If you don't draw it at all, you can just choose. Are there any questions on how this happened? No? Okay. So, if I could get you guys to, please send me your UID in the chat box, so I can enter things the way that I need to. If you don't want to send your UID out to everyone, you can go to this to button that's right here, and send it privately. Like if you just choose me, that works. Yeah, and then if you don't have any more questions, that's all I have. Yeah.